Alright, kiddos, so for the simulation circuit design, for this section here, where it says creating or constructing circuits, we're going to take this website link, copy it, and go to it. So it's going to bring you here to this website. You're going to click on this download button, and it's going to ask you to download it. So, put it on the desktop or downloads, save, and then click and open that HTML file. Okay. It's going to ask you for a lab or intro. I believe we're going to click on the lab part. Click on lab. Launch the lab. So here's the lab. And it says for number 2, drag a battery from the circuit plate on the right. Right click on the battery and set the voltage to 9 volts. So here's the battery. Let's drag that over. I'm going to click on it. And then you have a menu that pops up here. It says 9 volts. That's what we want. Alright, number 3 says construct the circuit displayed below using the default bulb and a switch in the open position. Note that your circuit will not look like the image below. You are to interpret the schematic diagram to create a circuit. We're going to check the voltage across the light bulb, record the measurements in the space provided below. Alright, when measuring voltage, getting a positive or negative value is dependent upon polarity or direction of flow. In other words, the 4.5 volt and negative 4.5 volt could be taken from the same source depending on placement of the leads. So let's make the circuit. Here we have our battery, we have our meter, and a bulb. So battery and a switch, so grab the switch, place it over there, a bulb, and a voltmeter. Alright, okay, so wire, grab the wire, attach it to the switch, grab another wire, attach it to the bulb. There's nothing else in this circuit, so it's just the bulb. I'm going to move that around, so you can grab these and move them around. Okay, let me just demonstrate this really quick. If I were to click on that switch, it closes it, the light bulb turns on. We can see the electrons flowing through this circuit. So I should be able to do something like this. There it is. See how it's showing that? If I move this over, it goes away. So the voltage across the bulb is 9 volts. What if we move this way? Do and do. Negative 9 volts. See the direction, the polarity, right? We did this, we got nothing. So this goes across. So that's 9 volts. So the voltage across the bulb is 9 volts. I think I just answered question 4. It says close the switch, so the bulb remains on. Alright, so let's open the switch. So for for number 3, what's the voltage across the bulb? 0. 0 should go here. Alright, now we close the switch. The voltage across the bulb is 9 volts. And across the power supply, so from here to here, it's going to be 9 volts. Alright, now we can check the current through the bulb by adding an ammeter. Record the measurement in the space provided below. An ammeter, so this is a voltage meter, so let's get rid of that. Put that back in there. Let's grab the ammeter. The ammeter needs to get connected in series with the switch or the bulb. So here's our battery, here's our ammeter, here's our bulb. So we can actually just get rid of the switch. So delete the switch, place the ammeter in here, and we get a reading of 0.90 amps. So there's our answer, 0.90 amps. Use the voltage and current that you have already determined for the circuit current I to determine the resistance of the bulb. Show your work and include the units. So our formula is right here. Current equals voltage over resistance. So we know the current is 0.9 amps. We know the voltage is 9 volts. So we're calculating for resistance. So you need to rewrite this to get the correct answer for this question. Alright, so I'm going to let you figure out how to do that on your own. Okay, let's go to an ohm table, right? Which one's a good ohm table? Ohm's law. Oops, this one. So let's look at this. Let's look at this table. Open image. So what are we looking for? We're looking for resistance. So if we're looking for resistance, that's equal to E divided by I, and E. Let's look at a better table. E is voltage, I is current, right? So if you were to divide those two, you would get the resistance. So that would be voltage divided by that 0.9. So it would be 9 divided by 0.90. So 9 divided by 0.90, that gives you 10 ohms. So it would be 10 right here. 10 ohms. Okay? So go to question 7, create the circuit, and continue working through this document.